I'm gonna make this as quick as possible because I don't have the iPad, and doing it on my phone, it'll take forever to upload if it's too long. Basically, we're starting inequalities, single variable inequalities. Just like a very, very basic example would be something like I have no idea if this will work out nice. Something like that, and I don't know why this keeps going in and out of focus. What the heck? That's out of focus now, isn't it? There we go. I'll try to hold it right there. Solving something like that, basically it's saying when is this side going to be less than or equal to 8. Simple basic ones like this where it's just a linear situation, you just solve it like a regular equation. Hopefully you guys have all seen this. So you could divide by 3 first or do distributive property, it doesn't matter. I'll just go 6 minus 3x less than or equal to 8. Subtract 6, you'd get negative 3x less than or equal to 2. Divide by negative 3. I'm not going to explain why right now, but you might remember whenever you divide by a negative when you're solving an inequality, you got to flip the sign so it becomes x is greater than or equal to negative 2/3. And then you got to plot it on a number line. A couple different ways of doing that. The one you've seen since 7th grade would be like, here's 0, here's negative 1, so negative 2/3 would be like right here. Since it's greater than or equal to, that number counts as part of the solution, so we'll shade in our circle, and then greater than is these numbers. All the solutions are all bigger, right? Alligator eats the bigger number, so all the solutions are bigger than negative 2/3, so we would shade to the right, and that just tells us any of these numbers over here plugged into this original equation will give us a number on this side that's less than or equal to 8. Another way of writing that though, on the number line, same idea. I don't know if you've seen it written with brackets and parentheses. It's just like the open circle, closed circle, but brackets mean the same thing as a closed circle, and parentheses mean the same thing as the open circle. So like this one, if it's greater than or equal to, you can put a bracket right there and shade it to the right, and those mean the exact same thing. But just if you solved it and you got like x is less than 1, you could do 0, 1. You could do open circle, shade it to the left, or you could do parentheses, since it's just x is less than 1, not less than or equal to, and shade it to the left. You should know both. I think your book uses the brackets and the parentheses, and this is what you've seen before. They mean the same thing. So that's just linear ones. You just solve it like a regular equation. Flip it if you multiply it or divide by a negative, you got to flip the sign. And we can talk about why tomorrow if you want. I'd also like you to try a couple that are quadratic. So something like x squared minus 3x. Let's go plus 5 is greater than, I don't know, let's make it factorable, so let's go 15. You can, okay, well there's like 3 different ways of doing this, 3 different ways of thinking. Basically you're going to solve it like an equation, kind of. You're going to, I mean, if you're solving an equation with this quadratic piece in it, you know you're going to get everything to one side so that it's equal to 0 so that you could factor. And that's no different here. So we'll go ahead and subtract 15. So we'd have x squared minus 3x minus 10 is greater than 0. Factor, which I think is x minus 5, x plus 2, greater than 0. Now this is the weird part. You can't just take each one and say x minus 5 is greater than 0, x plus 2 is greater than 0. That doesn't work. It's not true. Again, we can talk about why tomorrow. So what you do is you do solve each one like it's an equation, and that'll give you 2 points, x equals 5 and x equals negative 2, and we're going to call those critical points. And the reason those are critical is because for this function right here, these are the x values that will make it equal to 0. And so if you think about it graphically, here's my graph of this. When x equals 5 and when x equals -2, the function is equal to 0. So it's going to be those 2 points right there. And the reason those are critical is because if it's equal to 0, that means it's either going to be positive and drop to negative through that point, or it's going to be negative and rise to positive through that point. And that's important because if you're trying to find which values of this that you could plug in that will give you results greater than 0, you only want the part where it's above the x-axis. So thinking about it graphically, the answer will make sense. Like, you know that is a parabola, or you should. We haven't done graphing yet in this class, but you should know that's a parabola opening upward. So basically this is saying, when will this parabola take on values that are above 15? So I don't know what the graph of that looks like. I know it's got a y-intercept of 5. So just real quick, it's either over here or over here. Doesn't matter. My point is, it's asking, when will that thing get above, oops, sorry. It's either over here or over here. It doesn't matter. When will that graph be above the y values of 15 is what it's asking. So you should know, just thinking about it, that it's going to be whatever 2 points you find where it's equal to 15, which basically we did here because we subtracted 15. Your answers are going to be to the outsides of those. Or if you think about graphing this one, I know those are my x-intercepts or my zeros, so I know that graph looks something like that. And when I want to know when is it greater than 0, well, it's going to be to the outside of those 2 points. So just thinking it through like that, you could write your answer and say, hey, x has to be less than, is this equal to? No, just greater, just less than. X has to be less than -2 and greater than 5. So you could write it like that. Or you could just say -2 and 5. X, let's see, we got to be smaller than 2 but bigger than 5. So you could write it like that and then put it on a number line. -2, 5. It's non-inclusive, so you could have open circles, or let's do brackets and parentheses. Parentheses going outward. So that's if you could think about it and picture the graph, you can come up with a solution. If you don't know what the graph looks like, which some of these that we'll start getting into you won't, but you take these critical points and you set up test regions. So you say, hey, I know from -infinity to -2 that thing's either, oops, sorry. I know from -infinity to -2 this function's either going to be above or below 0, and then right at -2 it's going to cross through 0, and then it's going to be above or below, I don't know which one, somewhere in here, and then at 5 it's going to cross again and go from positive to negative or negative to positive. I don't know what's happening if I don't know what the graph looks like. But then I could just pick a number in these regions and test it back into my original inequality and see if it's true. So like for example here, between -infinity and -2, I just pick a point and I'm like, oh, I'll pick -3. And I plug it into the original. So I go -3 squared minus 3 times -3 plus 5. What's that? 9. 9 plus 9 plus 5, 18 is 23. Is that greater than 15? Right, because it was greater than 15. Yes, it is. That's true. That's a true statement. And since that one worked, all of those will work, because that's just telling me it must be above, and then it comes below through that point. So all of those will work. If you were to pick a point in the middle and test it, like 0, 0 is always a great one to test. It's easy. Plug that in, 0, 0, 5 is greater than 15. That's what you'd get. Is that true? Obviously not. So none of those points on the inside would work. And then pick a point above 5, like 6. Do the same thing. You'll get a true statement, and you'll realize, hey, all of those will work. And so then you could draw your conclusion, same as over here. Like say, hey, oh, x has to be less than -2 or greater than 5. And write your answer like that. So I'm already at 10 minutes here. Crap. So I was gonna do absolute value too, but I guess we'll save those for tomorrow. For your homework, what I want you to do right now for the rest of the class, I don't have my book. I don't have any of my stuff. I wasn't planning on being gone today. So you need to find the inequality section in your book. It'll be in the P's, chapter P somewhere. I couldn't tell you which one, P.5 or 6, somewhere in there. And then you need to find the problems, and I want you to find, don't pick anything with a fraction because you'll get them wrong. So don't pick like, you'll be like, oh hey, that one looks linear. If you get something like that. Unless you already know how to do these from Stanberry. But you probably, I don't know if you did these or not. So pick let's see, since we're only doing that, pick 4 linear inequalities and pick 4 quadratic inequalities and solve them and write your answers on the number line. It'd be nice if as a class you could pick the same 8 problems. So I mean, this video is what? It's going to be 12 minutes long max. You guys should have plenty of time, talk to each other, pick the same 8 problems, do them. We'll go over them tomorrow, and then we'll add in absolute value. Okay, bye.